Welcome to the Real Estate Espresso Podcast, your morning shot of what's new in the world of real estate investing. I'm your host, Victor Menashe. On today's show, we're talking about a meaningful shift on construction sites. But first, I'd like to invite you to take a look at our Y Street Capital Storage Fund. If you're at all interested in boring but predictable investments, the Y Street Capital Storage Fund might be just right for you. Now, this is not a solicitation for investment. That would be by prospectus only for accredited investors residing in the U.S. and in compliance with SEC regulations. Pay a visit to ystreetcapital.com and register for our investor portal. Be happy to share what we have going on in our Y Street Capital Storage Fund. On today's show, we're talking about a shift on construction sites. We're talking about robotics that translate CAD drawings into dimensionally accurate framing layouts directly on the job site. It's not science fiction, it's happening today. For decades, the process of laying out the walls has been surprisingly low-tech. It usually involves a big fat pencil. The most experienced member of the framing crew would take the printed drawings, a measuring tape, some chalk lines, and hopefully nothing drifted. Errors were common, especially as buildings became more complex and the tolerances got tighter. Every mistake cascaded downstream into framing conflicts. The state of the art today replaces that manual translation process with a robot. The most widely deployed example is from a company called Dusty Robotics and their field printer system. The concept is straightforward. The robot takes the CAD model and prints the layout directly on either a concrete slab or a wooden deck using ink at full scale with millimeter level accuracy. The wall lines, the door openings, column grids, even labels can be directly printed where the framer needs them. Another major entrant is Hewlett-Packard with their SitePrint robot. HP brings a decade of large format printing expertise into construction. SitePrint performs a similar function, translating digital models into printed layouts on concrete floors. The significance here is not just accuracy but repeatability. A robot doesn't get tired, doesn't misread a dimension, and it prints exactly what's in the drawing every single time. Third company worth mentioning is called Rugged Robotics, which focuses specifically on layout robotics for commercial interiors. Their system integrates with common CAD flows and is designed for active job sites where the trades are already working. That matters because construction rarely happens in a clean, empty environment. So what is the practical impact? First, speed. Layout that might take a crew 1 or 2 days can often be completed in a few hours. That compresses the schedule and reduces idle time for the framing crews. Second is accuracy. When the walls are laid out exactly as designed, the downstream trades do benefit. Mechanical, electrical, plumbing face fewer conflicts. There's less rework. That translates directly into lower contingency burn. Third is leveraging your labor. We're in a persistent skill shortage. Layout is specialized work, and robots allow a smaller team to do more and do it more consistently. As with any new technology, there are some limitations. One of the most important limitations is at the edge of the floor. Robots rely on reference point and stable surfaces. At the edge of a slab, on a balcony, on step slabs, or areas where physical structure deviates from the model, human judgment is still required. The robot can print up to where the surface exists, but it can't infer geometry beyond that physical boundary. Layout at a slab depression, on shear drops, or complex edge conditions often requires manual verification. Another limitation is the model quality. Robots will not fix a bad drawing. If the CAD model is incomplete, if it's miscoordinated, or if it's wrong, the robot will faithfully reprint the mistake. That actually raises the bar for design discipline. Teams that benefit most from robotic layout are those with well-coordinated models and clear construction intent. There's also practical constraints around vertical layout. These systems are excellent for floor layouts, but they do not replace elevation control. They're not going to make your walls plumb or multi-story alignment by themselves. They're a tool, not a replacement for competent supervision. So from a developer's perspective, the real question is not whether the robots are cool. Yes, they are. The question is whether they reduce the risk. The answer, in my view, so far is yes. Now, we haven't used them yet on our own job sites. We're just looking at demos. Layout errors are a hidden tax in construction. They rarely show up as a single catastrophic failure, but they appear as small inefficiencies, adjustments that need to be made in the field, and certainly in terms of rework. The technology aligns with a broader trend we're seeing across construction, which is to shift from craftsperson-type processes to repeatable, systemized execution. Will every single project justify using it today? No. Small projects with simple geometry might not see the benefit to offset the cost. Now, the way these are priced, now I don't have exact pricing, but they seem to be priced based on a daily usage model. So you don't pay for the machine, you pay for 1 day worth of use. I don't have quotes on it yet. Over time, I expect that to become standard practice, much like GPS-guided grading equipment is used today in civil construction. At first, it was optional. Today, it's pervasive. As investors and developers, our job is not to chase the next shiny object. It's to understand which tools improve execution. Robots that translate digital intent into physical reality accurately and repeatably are definitely worth taking a look at. As you think about that, have an awesome rest of your day. Go make some great things happen. And we'll talk to you again tomorrow.